Good morning, good afternoon, or maybe happy lunch and learn for some of you. This is Jim Raffle with ColorMetrix Technologies, and we want to thank you for joining us for the Color Control Myths and Mysteries webinar part 4, which we are putting on with our partner Mutoh America. Let's move past this title slide. Again, I'm Jim Raffle. I'm the CEO of ColorMetrix Technologies. We've been building color verification and process control software solutions for almost 20 years now.
And I'm Shelby Sapusik. I'm the project manager of ColorMetrix Technologies. I've been with ColorMetrix about 3 years, and before that, I have 17 years in the newspaper printing industry doing pre-press and production.
And we have a special guest with us both last week and this week. I'll let Chris introduce himself.
Oh, hi, my name is Chris Brown. I'm the engineering manager for Mutoh's Advanced Engineering Group in Phoenix, and I've been with Mutoh for about 18 years now.
And Chris is also our resident G7 expert as certified by ID Alliance, and he is the creator of the G7 CurveMaker module, which we'll be talking about today, and also the creator of the Mutoh SpectroVue spectrophotometer, which is also part of today's presentation. So we are utilizing the GoToWebinar platform for our webinars this week, as in past weeks. Just want to make sure that if you need to ask a question, some of you may have used this platform in the past, and there's an option to raise a hand. We don't utilize that during our webinars. Instead, there is in your control panel an area that you can enlarge or break out, and it's called questions. If you please just type your questions in there at any time throughout the webinar, we'll kind of keep an eye on that. And if it's a question that's kind of one-on-one, we'll type an answer back to you. And if it's a more general question, we'll work it into the presentation so that everybody can hear the answer.
So throughout our webinars, what we've been trying to do is open the door to consistent color. If you've been with us for the past 3 webinars, you've seen this image. What we're trying to do is say the red patches at the top, that's our target, and the ones in the middle or the bottom are what we are getting out of our printing or our proof. And obviously what we want to do is match our target. So that's been our goal throughout the entire webinar series. Our agenda today, we're going to do a very brief review of the first 3 webinars. We're going to talk about process control with industry standards and specifications. We'll do a brief DeltaE review. We'll talk about why brand colors and with ICC profiles are important. And then we're going to get into the introduction of Mutoh ColorVerify with the new G7 CurveMaker software.
And of course, Q&A at the end.
Yes.
So one of the things we've done throughout these webinars is to start with a visual trick or an optical illusion potentially. And it's really to reinforce the fact that while the eye is an unbelievably good comparator of color, it can also be very easily fooled. So as we look at, don't see an image. Oh boy.
Hold on.
Yeah.
1 second.
I apologize for that. We're going to have to, I don't think we need to go back though at this point, right?
No.
So, all right, I apologize for not having the image displayed. Thank you for letting us know. So as I was saying, this is the optical illusion that we like to start with an optical illusion. And in this case, we've got one with 2 grays displayed on the left and the right side, one with a yellow background and one with a kind of orangey brown background. And what we're going to do now is we're going to pop up a poll question, and that poll question is going to be, are these grays the same or not? So that question should be launched now. So if you could all just take a moment and weigh in what you think. Give you guys just a few more moments to answer these questions. All right, it looks like everybody who was going to weigh in probably has, so we'll close out the poll and I'll share the results. Well, actually, what I'll do before I share the results, well, I guess we'll do it this way. So about 75% of you think it's the same and 25% don't. And let's see who's right. All right, so it is the same gray. And what's happening here is we're getting a more and more educated audience, and that's probably because some of you have attended some of the previous webinars and have seen that surround color can dramatically affect your ability to differentiate, especially something like a gray. But obviously, we've still got some folks along who can benefit from some of the things that we're going to go through.
So here's our review of the first three webinars. Part one, we talked about just color myths in general. Some of them were simply, you can trust your eyes when it comes to color, or your printer will always match your proof. We had three other ones, and we went through and basically debunked all the myths. In part two, we discussed the biology of the human eye and how that affects color perception. We talked about RGB and CMYK and the differences there, and we gave a brief intro to LAB color space. Part three, we talked about CIEXYZ color space, described color more with LAB. We talked about different DeltaE tolerance methods, and we had an intro from Chris Brown of Mutoh to the G7 method. You can see those recordings at colormetrix.com / it should be Mutoh webinar. I'm sorry, MUTOW webinar. Sorry, that got by us somehow. And we will have part four after probably by Monday.
By Monday morning.
Yeah, on the website as well.
All right. So part four really focuses on process control, and specifically with ColorVerify. The previous three parts were really to provide a foundation to understand how color process control works in the graphic arts, printing, and wide format industries. So we are definitely going to focus very heavily on process control because G7 CurveMaker is an integral part in a process control solution. So we'll talk about what process control is, why we do it, who engages in it. Because of that, we have to circle back a little bit and review DeltaE because that's a key component of how we do process control in this environment. We're going to talk a little bit about industry standards and specifications, of which G7 and Grackle are, and then get into brand color verification and how that's part of this solution. And then finally, Chris is going to talk about the G7 CurveMaker, which in fact is how we solve a bunch of the color process control problems that our industry has. So let's start with what process control is. The first part of process control is the collection of data. It's important, however, to collect the right data. Some people are of the mistaken myth that you can't collect too much data. I believe you can. It's more about focusing on collecting the correct data for your situation. So if in fact what we want to do process control of is color, then we need to collect the correct data, the correct color data, to arrive at the end result that we want. And the way we determine that is by analyzing data and figuring out which pieces of color data that we collect become most valuable to us in, first of all, analyzing our current operational state to see if we're in control and we're producing color consistently, and also the pieces of data that are best at determining when we're out of control. By doing that, we allow ourselves to do what's called speak with data. All speak with data means is instead of looking at two prints and going, darn it, this one is too red, or this one is too yellow, this one's too warm, this one's too cold. Those last two examples I always hated when I was doing color in a shop to help achieve a color okay. There is no warmer and cooler button on any piece of printing equipment I've ever seen. So in fact, what we need to tell people is, here's my LAB values. They're 4 delta E out. Because they're 4 delta E out, we need to move this direction. So all of a sudden, we start talking with the kind of data that allows us to take corrective action instead of just realize that there is a problem. And then that's kind of our last piece. Act with the data that you've created so you can troubleshoot. So we do have a poll question at this point, and let me pop this one up. So our question is, do you currently have a formal process control program in place? And the honest to God answer is, if you don't know the answer, I would hope that you'd say no. So, and we just want to get a feel for who's using things like ColorVerify or our other product ProofPass, and there's a bunch of other products in the marketplace that you can use for color process control. And we just want to get a feel for who's doing it and who's not. All right, it looks like pretty much everyone's weighed in, so I'm going to close the poll. And the answer is not that surprising to me. About a third of you are doing process control, but 2/3 of you are not. So hopefully for those of you who are not, we can show you some ways to do it that are economical and easy. And for those of you who are, maybe we have something that can augment the systems you already have in place. All right, let's move on. I think this one is Shelby's going to explain accuracy and precision to you.
So when I look at this, we're talking about why we use process control. Jim just talked about what it is, and let's talk about why we need it. when I look at this diagram, let's think we're doing like target shooting practice. Okay, so on the left, you can see that we're trying to hit that the middle circle there. That's our target, and we shoot a half dozen times, however many that is, and it's precise. They're all in the same general area, but they aren't near where our target is supposed to be. So if that's our target color, we're kind of out here in a different quadrant. We're precise, but we're not accurate. On the right hand side, we're kind of all over the place around the target, but again, we're all over the place. So we're being accurate, but not precise. In the middle, that's what we want. We want to be both accurate and precise. We want to hit the target, and we want to hit the target consistently.
And I think what I'd add to this slide is that think of that red bullseye as, say, I don't know, a soft drink red that you're trying to achieve, and your printer is potentially printing up in that upper central quadrant or around the target, but not hitting it precisely. So, who uses process control? The main answer is that almost anyone who manufactures or produces a product and wants to maintain consistency uses process control. Uh, One great example is our partner today, Mutoh, uses process control probably throughout the manufacturing, not probably, they do use process control throughout the manufacturing process of your printer. Screen printers have been using process control for a long time to maintain film density or ink film thickness and things like that. Offset printers have been doing process control. That's part of the industry I came out of. Photographers have been doing process control in their film processors for decades, probably 50 or 60 years, with manual plotting techniques and things of that nature, back in the 50s and 60s. My favorite example, however, is Starbucks. And love them or hate them, you probably noticed if you drink coffee and you go to Starbucks that you can get the same equally good or bad, depending on your opinion, cup of coffee, whether it be here in Sussex, Wisconsin, where we're broadcasting from, or Orlando, where we're going to be for SGIA next week. And the way they do that is by a process control, not only of the beans that they make, but more importantly, what is coffee mainly? It's the water. So in every Starbucks store, there's a system called a reverse osmosis system, and they do testing of the water on I don't know what the frequency is. My guess is it's daily. They do testing of the water on a daily basis to make sure that the water is tasting the same and has the same mineral contents and things of that nature. And that's how your cup of Starbucks ends up tasting the same, no matter where you get it. It's all about process control.
So, what are the benefits of process control? Well, this is something we've been talking about throughout all the webinars pretty much. We're trying to lower costs and we're trying to get higher quality prints. We're getting lower costs because we're able to eliminate reprints and redos because of color shifts. So, if we can, again, if we're accurate and precise, we have consistent colors on repeat jobs, we can use different medias and figure it out. And we also have a nice documentation of the history of the printer using process control. Moving on to DeltaE, this is one of my favorite examples. We actually used this very example in a trade show booth with Mutoh a couple years ago now, hasn't it been?
In Orlando, I think.
I think it was. But what we had this printed out and then we cut it into 6 pieces. And we're saying, let's pretend this is your trade show booth and it's all done in panels and it's so big you have to print it in panels, right? And you use it over several trade shows and you're shipping it back and forth between home base and wherever that trade show is. And a couple of the panels get damaged. So here you are. And do you want to have to reprint all your panels or do you just want to reprint the 2 damaged ones? So we decide, we're just going to reprint the 2 damaged ones. And the 2 that we had to reprint was the upper left and the middle bottom. But as you can see, when we put it together with our other original pieces, you can tell that the upper left, that gray, those grays are a lot darker than the originals to the right. And then if you look at the middle bottom compared to the left bottom panel, you can see the difference in the reds pretty clearly. So we're kind of stuck, right? So now do we go back and reprint the whole thing again or reprint the original 4? We're wasting time and money. If this was a client, would you want to go back to them and say, sorry, we're going to have to reprint all 6 panels because we can't print the original we did 6 months ago, a year ago?
All right, great. So one of the things we can do is, if we have a process control system in place, we can use a measure called DeltaE. And DeltaE is a single number that represents the difference between two colors. So if we printed a control strip, which we'll show in a moment, that had a variety of colors on it and made sure that all those colors were within a certain DeltaE range, then we would be able to say that yes, if we now try and print those two panels that Shelby was speaking about, they will in fact be very close to what they were 6 months ago. And in fact, will probably be close enough that the client can't differentiate. A delta E of between 1 and 2 is basically the smallest color difference that the average person can see. I'm not going to say there aren't people who can see delta E shifts of less than 1 in certain color ranges, but on average, somewhere around 1, probably really honestly 2, except for some very light grays and pastel colors. So delta E is used to determine how much a device has drifted and basically the effectiveness of a profile for printing or proofing, and a variety of other things, but these are the two main things that we're interested in. So our industry, in the graphic arts as a whole, has established a bunch of standards or specifications or guidelines, and one of them is GRACO, which we're going to talk a little bit about today, because that's where G7 came out of. SWAP, which is the specifications for web offset printing, and then FIRST, which is for the flexo industry. These are all important aim points that you can start with. If you aren't sure where you want to start, what kind of color do I want to produce, these are great starting points. They may not be your ending points, but they're definitely great starting points to begin a process control program. And in order to do process control effectively, you're going to have to produce some kind of a control strip, something like you see here on the bottom, not our logo, but above that, the 54 patches, which is actually referred to as the ISO 12647-7 control strip, which has recently been updated, and we need to get a new copy of. I think Chris actually has an image of that later on. Do we have a poll question here or after this?
Oh, we can do it now if you like.
Well, we'll do it here. All right, so we have our last poll question of the day. And before we start talking about ICC color profiles, we're going to ask if you currently create your own custom ICC color profiles, and the alternative answer to that would be that you might use those that come with your media or provided by a manufacturer. Okay, excellent. All right, let me close the poll. Let me share our results. So honestly, about 50-50. Create your own custom profiles versus use either out of the box, maybe don't use any at all, whatever the case may be. So let's talk about profiles for a moment here. Whoops.
I don't think you want to do that.
So a color profile, it's a calibration of a media, so your paper, to your printer in an environment. So each media and printer and environment are unique. Only a custom profile that is made for your media with your printer and under the conditions of your shop will give optimal output. Now, Chris is going to talk about the G7 CurveMaker, which allows us to get, if we have 3 printers in our facility, it basically allows us to get all 3 of our printers to a very, very similar print condition. So in that case, you might be able, if you have 3 of the same printers and you've used the G7 CurveMaker methodology, you can probably now share one profile between those 3 printers. So that's kind of an exception, but it's still your printers in your facility with your media and your ink. And the reason all of that is so important is that environmental conditions like temperature and humidity that are going to be different in California and Arizona and Florida and New York and Wisconsin have to be accounted for. And sometimes you end up making a new profile winter versus summer, depending on your shop. So there are several levels of color profiles. Basically, your shop, your printer, and your media, that's a custom profile. Your printer type and your media, that might be one that's provided by a media manufacturer. Your printer type in a similar media, that's when you're in a pinch and you had to get a roll of media and you got to get something printed out. And a profile is only valid for the the mode and resolution that it was made in. All right. So each ink and printer has kind of a different color gamut, and that's the number of colors that it can produce. A brand color produced on a printer may not match a swatch book and be achievable from your printer. In other words, it's out of the gamut of your printer. The way to get around that is to produce a brand color test chart based on your printer ink and media. And you do this obviously after you've got your ICC profile. And then you let your customer pick and approve a color produced from your printer. That way, you know, it's always achievable. And then your RIP, many of the RIPs have essentially a spot color replacement tool. And what that allows me to do is say that whenever I see this color number, this PMS number, I want to replace it with this color number or this PMS number. Now, all of that only works if you've got a G7 base. In other words, you've calibrated all your printers to a known condition and you've put valid ICC profiles on top of them, and you're doing ongoing process control. Which leads to our ColorVerify Pro with G7 CurveMaker demo. First, we've got kind of a cool video here that Chris put together. Hopeful. There we go. Oh, animation's going a little slow. So basically, Mutoh's tagline, Mutoh's tagline is creation. So I'm going to click to the next slide, and I think at that point we turn it over to Chris, right? Try and click to the next slide. There we go. Chris, you're on.
Okay, thanks, Jim. So ColorVerify Pro G7 is a product that we developed jointly with ColorMetrix. And what it does is it adds a G7-based process control to the existing ColorVerify workflow. So we have our current ColorVerify solution that we've had now for process control. And what we're doing now is we're adding a G7-based calibration into this. It integrates with most RIP software. And what it does is it allows you to replace the conventional linearization step with a G7 calibration. So if you've ever built a media profile for your printer, most RIP software requires you to go through and you set initial ink limits, you do linearization, where you're effectively calibrating the printer to itself, and then you build your ICC profile on top of that linearization. What we're doing here is we're replacing the linearization step with the G7 calibration so that we're now calibrating the printer to an industry standard set of aim points, a device-independent set of aim points that are defined in a publication called ANSI CGATS TR015-2011. And that standard defines aim points for calibration of an output device across multiple industries. So whether you're dealing with large format printers, you're dealing with digital presses, offsets, flexo, all of those machines can be calibrated to G7 aim points and establish a known good condition. And then you can put your ICC profile, you can build your ICC profile then on that foundation. The benefit here is that we are calibrating to a known good condition that we can calibrate back to at any point in time. So using ColorVerify, you can test color reproduction accuracy day to day, job to job, and you can also then quickly adjust your machine back to that known good condition should color drift occur during production. So here we see a workflow of how this process actually works. So the calibration begins by printing the G7 CurveMaker chart, and this chart is generated by ColorVerify to take advantage of your print width. So in the case with the Mutoh printer, if you're printing on 60-inch media, then it's going to print that chart. It's going to generate that chart to fill the full width of the media to minimize media waste. And the chart itself is really no bigger than a traditional linearization chart. So there's no more patches, there's no more time to do the G7 calibration that would be to do the traditional linearization. You can set ink limits within ColorVerify, which sometimes has to be done depending on the material that you're printing onto and the resolution and your drop size. So you set those ink limits in ColorVerify. Those then get rolled into the chart. So the chart is actually created with those ink limits, and then when we go back to build the actual calibration curves, those ink limits actually get rolled into the curves themselves. We then print the charts through your RIP software with no color management enabled. And then at that point, we measure the chart using the ColorVerify software, the ColorVerify client, and our SpectroVue spectrophotometer, which actually is placed on the printer itself. ColorVerify then takes that data, creates a set of calibration curves And those are the calibration curves that then get imported into your RIP software. We generate a verification chart. We print that verification chart to verify that we are hitting our G7 aim points. In that verification chart is also a set of data that we use as a baseline, so we can then verify that once we've built the calibration upon which we're going to build the ICC profile, that the printer then stays in that known good condition. So then periodically throughout your production run, you are periodically printing, reprinting that verification chart. You are checking those process control patches against your baseline, which is uploaded to the ColorVerify server. If you get a pass, everything's fine, you continue printing. If you get a fail, then the ColorVerify client is able to take that data and reiterate your curves, load those back into the RIP, and you're ready to go. Next slide. Okay, so here we see in the ColorVerify wizard, this is basically the setup. So before you generate the chart that you're going to print, this is where you would set your ink limits. Next. And then you would then save the, there we go, you would then save those, you would save the chart to some location that you could then open that chart back up in and reprint it. You can save the chart as a TIFF file, you can save it as a PDF, you can drop it into a hot folder with a lot of RIPs will support, and it will automatically print it. The key thing here is that when you do print this chart, this is the first step that you're going to do in the building of a media profile. And so rather than doing the ink limits and the linearization step in your RIP software, you're actually going to build this G7 chart, output it as a TIFF or a PDF to your RIP, and then from your RIP with no color management, you would then print that chart, and then you would go back to the ColorVerify software to actually do the work. And the next slide, we can see what that chart actually looks like. So this is the CurveMaker chart. This is the chart, and you can see there's really no more patches in this than you would have in a typical linearization chart. There's an enhanced version of this with more patches if you're printing onto material that may be difficult to read. There's some scrim vinyls and other materials that are not always very consistent when you're measuring them with spectrophotometers, so there's an enhanced version which does have more patches, but this is the typical, this is the normal patch set. And again, this could actually be spread out across the width of your media, so in the case of, say, a 60-inch wide media, this may represent only one actual line of patches, and with the SpectroVue, it would actually read this in a couple of minutes. And I think we have a little video. Oh, okay, so once you would then actually print this from your RIP software, and the CurveMaker wizard or the CurveMaker or the ColorVerify software, the client would then wait for that to be printed, and then it would take the measurement. And in this, we have a short video of the SpectroVue, and you can see it actually mounts. This is our device. It mounts on the head of the printer, and it actually takes those measurements automatically. And this makes it nice because you can actually do those measurements then during production. You don't have to sheet anything off. We do this when we print things for trade shows and things we go to, where if we're printing off a row of banners, we may print a few banners, and then we run a strip, check it, and then we just continue printing. We don't have to cut anything off or measure anything by hand. So it makes it nice, fits into the production workflow very easily. So then what happens is that the ColorVerify software will use our CurveMaker utility to build the G7 calibration curves, and it will then save those curves as an import file for your RIP software to be able to import. So for this to work, you do need to have software that actually allows you, RIP software that actually allows you to import curves in lieu of linearization. Some of the RIPs out there that support this, SAI with its FlexiSign, FlexiPrint software, Onyx Production House. I believe Wasatch has an option to import G7 calibration curves. There are several RIPs out there that already support this capability. They all do it slightly differently in where that process actually takes place, but this side of the process pretty much always works the same. And then this is what the curve data would actually look like. So you can see it's not that much different than the linearization data that you would get. The curves sometimes look a little different in their shape. What happens here is you can see your CMYK curves. Your cyan, magenta, and yellow curves are actually created in such a way as to produce a process grayscale which conforms to the neutral density endpoints that are defined in the TR015 specification. And similarly with the gray curve, that again, instead of being simple linearization curve, what you have here is a K curve that actually then allows the K channel to also meet its endpoints. In the case of the process gray, we're meeting both density and colorimetric endpoints, and in the case of the K only grayscale, we're matching density endpoints. And these endpoints, even though the curves are going to be different because they're dependent upon the media that you're printing onto and the ink that you're using, so the curves for any given device are going to look different. But once these curves are imported in the RIP, every printer and on whatever the media that you've done this on, whatever ink that you're using, whatever output device you're using, they're all going to produce the same, hit those same grayscale endpoints, and that's going to bring all of the images that you print on those devices, even before you do the ICC profile, bring them to a very consistent visual appearance. And then this is what the verification chart looks like. It's a little bigger than the original calibration chart. This verification chart, the top third of that, has the color data that we actually use to monitor whether or not the device is actually, the printer is actually staying within spec. And then there's an actual process grayscale that we look at to make sure that we're still hitting our G7 endpoints. There's a K only grayscale that we look at to make sure we're hitting those endpoints. There's also the CMY gradients, and from that CMYK gradients, I can also recapture what my curves were. So when I read this verification chart, if I do have a situation where I've drifted and I get a fail, I can say, okay, what were my curves? I can pull those curves up by reading this chart, and then the bottom third of that has the same data that I used to build the curves in the first place. That's the G7 calibration part. I can then use that data to reiterate the curves. And so from this one data, I can print that one chart out, measure it, verify that everything is good, and if something has changed, simply reuse that data. Take that data without having to measure anything else, reiterate my curves, re-import those, and be back to the known good condition that I was in when I created my profile in the first place. That is how I'm going to maintain consistent color throughout a production run, or as Shelby showed earlier, when this client comes back to me and says, hey, we printed these 6 panels for this trade show, one of them got damaged, I need to reprint it, and I'm looking at this and saying, okay, what was the condition of my printer 6 months ago? Can I just use the profile I have today? Am I going to get the same color? Well, that profile was built for a given condition of that printer, but now I can say, absolutely, I can match those colors, because I can dial my printer back to a known good condition, and I can be confident that the condition that I'm using today is the same it was in 6 months ago when I printed the originals. And if something has changed within my system, by redoing my G7, by reiterating those G7 curves, I'm going to be able to duplicate that condition that it was in at the time when I made the original prints. So I'll be very confident that I'll be able to hit those colors and just produce one panel instead of having to produce all 6. This is a verification report that comes up after you've printed the verification chart. You get this report, and it shows you some data up top, just your media white point, black point, some other things. The important stuff are the last 4 lines at the bottom. These are the actual aim points that are defined in TR015 that actually are what we would call the G7 aim points. And so this is what I'm actually looking at. So when I print this verification report, along with getting a pass-fail from the ColorVerify software and a list of DeltaEs and showing me where I might be have drifted, I'm also going to be able to look at this and verify that, yes, I'm within tolerance, I'm hitting my tolerances, or I'm not, and how far off I may be from where I actually might want to be. So those last 4 lines, when you look at TR015 and you look at the G7 specification, which we talked about last week, those would be the aim points that I've hit, and I can look at this and say, yes, I'm good. And I can then archive this data and pull it back up at any point in time and say, okay, where was I 6 months ago when I printed those originals, and I've got this verification data that's archived. And so when we're printing in Phoenix, we're maintaining records of this data as part of the archive, and this would be the same thing then that would get stored on the ColorVerify server, so you can have an archive of your process.
All right, Chris, thank you. So what Chris has been talking about, for those of you who may have already seen ColorVerify, is the G7 CurveMaker functionality, as technical as it is, and Chris gave an excellent, really non-technical description of something that's very technical. We've hidden or masked all of that complexity behind the existing ColorVerify interface that we built for Mutoh. So as an end user, this is really more like what you're going to see. After the printer does its measurement step, you're going to see a single panel in your wizard that basically gives you a pass or a fail status. Obviously, if you pass, everything Chris just talked about is good. You're good to go. If you were to fail, all it's going to do is start the G7 CurveMaker wizard back up and step you through that process. Now, as Chris said, the verification target already contains all the data that he needs to build a new curve. So you're not going to have to reprint the G7 curve target. You're just going to have to tell the software where to put the regenerated curve. You're going to have to pull that into your RIP, and then you're good to go. So just a couple steps, and you're back on your way. Chris also made, let's see, I do have another slide here. There we go. Chris also made mention of pushing it up to the internet or up to the cloud. This is an example of what our cloud-based interface for ColorVerify looks like. It shows you what the control strip looks like. It gives you all the really granular LAB and density values if you really want them. This is really more of a troubleshooting tool for technicians. If you're recurving, you're creating new curves and you're still not getting where you want to get. Because this is all internet-based, you can allow technicians from either Mutoh or your dealer or a third-party color management expert, you can allow them to just log into the internet from anywhere in the world and look at the data you've created and potentially help you solve your problem remotely. So that's one of the advantages of a cloud-based solution like ColorVerify. So that wraps up our description of ColorVerify Pro with G7 CurveMaker. We hope that you'll be able to join us in Orlando at SGIA, where we hope to have an actual demonstratable version of this. We've got it working in the lab. We just haven't gotten it quite to the point where we're ready to show it to people, but we plan to be doing that at SGIA next week.
And of course, our main goal is always to try to open the door to consistent color so that we are hitting our targets, so that our benefits are that we're not wasting time and money on reprints and redos that are unnecessary.
So again, I spelled it right here.
Yes.
So the first three parts of the series and this part by Monday will be at our site, colormetrix.com/Mutoh webinar. Your other next step is work with your Mutoh sales rep or your dealer. You can get a free 90-day trial of ColorVerify, both the existing version and the version with G7 CurveMaker when available, as long as you own a VM10, which is the SpectroVue instrument. As we mentioned, we will be at SGIA in Orlando Wednesday, Thursday, and Friday in the Mutoh booth, number 248. You can come and meet Chris, Shelby, and I, and we will show you as much as we can about ColorVerify while you're there. And if we have any remaining questions, first of all, speaking of questions, I want to thank John and Jerry for letting us know that we hadn't shared the PowerPoint. I apologize for that for those of you who have been here since the beginning. And my friend Michael always has a smart comment, so we'll skip that one. And Jason, we will email you an answer. I think Shelby's done some research and has an answer, so she'll email that to you. So at this point, if anyone has additional questions for any of the three of us, we've got some time, and we'll leave the floor open and give you guys a couple 3 minutes to formulate your questions. If we don't get any, we'll end the webinar. All right, I don't see any questions coming in. Oh, there we go.
Yes, Regina, you can.
Regina wants to come and spend a week learning from us. I guess there's three of us though, but Regina, I think there might be some classes in the future that we might hold in conjunction with Mutoh around the country when ColorVerify starts rolling out. So there might be a way to make that happen coming up.
If you haven't already, Regina, to keep updated, please go to colormetrix.com and sign up for our newsletter. We don't spam anybody, but we do all these webinars often enough where we let people know when they're coming up and give you a lot of advance notice.
And she would, by signing up for the webinar, you're already signed up.
So, did you do that? Okay,
yeah.
Sorry.
I imported all of those names. All right. Well, it looks like at the moment we're not going to have any additional questions. So I would like to, first of all, thank Chris for joining us again. And I
Yes,
would like
thank you, Chris.
say thank you to all of you. Thanks, Chris. And I would like to say thank you to all of you for your attention in both this webinar. If you've attended the previous ones, thank you for that as well. I'm not sure when our next webinar will be, but these 4 will be recorded and available to view at your convenience. So with that, thank you, and we're going to end this session.
Thank you, everyone. Have a great weekend.